All right, we're back. This is going to be page 87 of math analysis, and we're going to talk about some of the weirder things, or I like to call them squirrely things that can happen as you are trying to solve trig equations. So just like when you're solving algebraic equations, you can occasionally you do something to the equation, like maybe you square both sides, right? And in so doing, you might introduce extraneous solutions. So we have to be on the lookout for extraneous solutions occasionally. And basically, the rule that I use is if you do something that you think is kind of weird, you should probably check your answers because you might have introduced the possibility of extraneous solutions. So let's take a look and see what that means. So we want to solve sine of x plus cosine of x equals 1. So this is a problem because basically if there's more than one trig function in your equation, like what are you going to do? So we have to find a way to deal with this. We could try changing cosine into sine using cofunction identities. We could try using Pythagorean identity. But what I think I'm going to do, which is the much more standard thing to do, is I'm going to also, you should know, you could probably just guess the answers to this question, right? Like, I don't know, like we need, if cosine is 0 and sine is 1, this would work, right? And that happens at pi over 2. If sine is 0 and cosine is 1, that would work. So that happens at 0. So like 0 and pi over 2 seem like they both work. But how do you know that, like, I don't know, like pi over 18 doesn't also have this property? Like, what we want to do is actually come up with an algebraic way of doing it. So what I'm going to do, and this is a common thing to do, is I'm going to square both sides of this. So I'm going to start with the original. So we have sine of x plus cosine of x equals 1. And I'm going to square both sides. So when I square both sides, I'm like sort of basically going from like a linear to a quadratic. And a quadratic can have twice as many solutions as a linear. So now I'm really going to need to check everything. But let's see what happens. So we get sine squared plus multiply them together is sine cosine times 2 sine x cosine x. And then square the last. It's cosine squared. And this equals 1. So what's kind of nice, though, is we see this, which is the best of the identities. Cosine squared plus sine squared plus cosine squared equals 1. So really we have 1 plus 2 sine x cosine x. And like, we might have been in trouble if this didn't end up working the way it does work out, but it's working out that way. So we'll come up with other ways to deal with it when it doesn't work this nicely. So here we get 2 sine x cosine x equals 0. So if this is the case, then either sine of x equals 0 or cosine of x equals 0. All right, so either sine of x equals 0 or cosine of x equals 0. Let's think about this. So if sine of x equals 0, unit circle, the y value is 0. So this is going to be x equals 0 plus 2 pi n, or x equals pi plus 2 pi n. So if you are really on the ball, which I'm thinking a lot of you are, you might be thinking, why didn't you just write 0 plus pi times n? Well, for reasons that we want to look out for is why I didn't do that. And I just happen to know how this works out. When you're solving trig equations, it's better to go with like the multiple generating functions for your solutions rather than try to like simplify it. And it has to do with the signs in the quadrants and along the quadrantals. And you'll see as we check it. So here I'm going to say if cosine is 0, either x is pi over 2 plus 2 pi n, or x is 3 pi over 2 plus 2 pi n. All right, and then for all of these, n has to be an element of the integers. All right, so we have these, but we need to check, right? Because we squared, and we're going to check in the original. I don't know what this is doing. Okay, so I'm going to make a table, I guess. Am I going to make a table? Sure, why not? Where it's going to be x, and then sine of x plus cosine of x. All right, and we have to check 0, pi, pi over 2, 3 pi over 2, to see if these work. All right, so at 0, the sine of 0 is 0, cosine of 0 is 1, so I get 1, so that works. At pi, the sine of the sine of pi is 0, but the cosine of pi is -1, so this does not equal 1, so this is out, which means that this pi that showed up is extraneous. So we get extraneous solutions when we do weird things, right? We like either change the domain of the function or we change the degree of the functions involved. A lot of stuff going on. In this case, we changed the degree and things went poorly. Sine of pi over 2 is 1, cosine of pi over 2 is 0, so this does equal 1, so that's good. Sine of pi over 2 is -1. Sorry, sine of 3 pi over 2? I don't know what I even said. Sine of 3 pi over 2 is -1. Cosine is 0, but this does not equal 1, so this is out. So we go back over here. I'm going to cross this out. It's also extraneous. So our final answer, or answers, I guess, are 0 plus 2 pi n, or pi over 2 plus 2 pi n. But like we can't do the pi n thing because it doesn't work. So you have to be really careful when you're doing these problems. So what went weird there is that we squared both sides. So we went from essentially a linear thing, everything was to the first degree, up to a quadratic thing where we introduced like some second degree things. Even though they ended up like going away, we squared it. We made it higher degree. Higher degree equations can have more solutions. So some of them, maybe all of them, could end up extraneous. So that's why you definitely need to check. I'm also going to try this one here while we're here. So we got tan squared plus 2 secant plus 2 equals 0. Well, we're in trouble because basically anytime there are two different functions, like what are you going to do? So what I'm going to do is I'm going to look at this and look for something that I know, right? So I definitely know, well, I think I know, that I can turn tan squared into something involving secant squared because I know a Pythagorean identity, right? So I know that tan squared of x plus 1 equals secant squared of x. And what's really convenient about that is that the other function in this equation is secant. So I think we're going to be able to deal with this. So I want to replace tan squared, so I'll replace tan squared with secant squared minus 1. All right, so I'm going to do that. Now, this is less risky because we're just using identities. But since it's strange, I'm going to check my answer anyway. That's kind of the way that I decide if I'm going to check. Honestly, you should probably check all of your answers no matter how you're doing the problems. But like solving trig equations is a lot of work, so sometimes you get a little lazy. So I'm replacing my tan squared with this, and then keeping the rest. Plus 2 secant plus 2 equals 0. So my equation is secant squared plus 2 secant plus 1 equals 0. So that's factorable. So secant plus 1 squared equals 0. So that means that secant of x equals -1, which also means cosine equals -1, but that's not as hard to think about, so I'm not actually going to change it. Where does cosine equal 1? X equals pi plus 2 pi times n, where n is an element of the integer. So what I'm going to do is I'm going to check my answer because although I'm pretty confident, it's possible that the original equation, which had tangents and secants, might be undefined at pi. So you want to check for that reason. So I'm going to check the tan squared of pi plus 2 secant of pi plus 2. I just want to see what this equals. So the tangent of 0 is 0, and the period of tangent is pi. So the tangent of pi is also 0. So this is 0 plus the secant of pi, we said was -1 plus 2. This equals 0, so it checks. So this is my solution for sure. I think it's a good idea to check your solutions when you're solving these sorts of things. So what I'm going to do really quickly is check both of these on a calculator because it's something we should do. And then I will cut this video off. So let's see how we did. we're solving sine of x plus cosine of x equals 1 for x. And so what do we have here? So the first solution here with n10, I should really like start a new document, is just 2 pi n, which we had. Second one's written really weirdly. Let's expand it. So expand is menu 3 on the handheld. So it's pi over 2 plus 2 pi n, which is what we had. So good, checks out. Let's try the other one. Solve tangent of x squared plus 2 secant of x plus 2 equals 0 for x. And so let me expand this. So this is giving me negative pi plus 2 pi n. It's so weird. Which if I had pi, it's just giving me pi plus 2 pi n, which is what we ended up with. And so we got it. So good work, us, I guess. So if you're careful when you do these, you got to remember all your identities. You got to remember your unit circle. You got to remember a ton of stuff. Check your answers. Anything weird that you do, check your answers. You're going to be okay. So I will be back in the next video to do the next problem, and I will see you there.